All right, we're going to look at 9-3 today. So let's double check that we remember how to add and subtract fractions with unlike denominators. And so we know based on all of our years of math that we want to make sure we have a common denominator. And you may be easily able to see here that 5, we could increase that number in the denominator to get it to be 20 by multiplying by 4. But remember, we have to multiply by 4 in both the numerator and the denominator, so that way we're really not changing the value, because this is just 1, right? So make sure you're doing the same thing in the numerator and the denominator. So this becomes 8/20 plus the 7/20. I'm not changing this one. And now that I have a common denominator, remember we keep the denominator the same, we add and subtract across on the top. So 8 plus 7 is 15. 15 over 20 is 3/4. So that's a very quick review over our fractions, okay, of adding and subtracting on denominators. Okay, so the next one, we now have 3 denominators to consider, a 4, a 9, and a 3. And again, we're wanting to come up with the idea of a least common denominator, your LCD. And so what is the smallest number that all of these go into? And it may help you to list your factors out. So some of you may see this right away. That is fine. If you don't, then you want to list your factors. 4 is really 2 times 2. 9 is really 3 times 3. 3 is just itself. So pay attention to this trick, though, because this is when we're going to start seeing this trick being used in the next couple examples when we're involved with variables. So the trick is to get the least common denominator after you factor everything. Look for the groups with the most repeats. So out of each factor that you see, out of each thing that's being factored, what is the most amount of times that you see that factor repeat itself in one given group? 2 repeats itself twice here. 3 repeats itself twice here. This 3 is only once. So I'm going to go with the highest amount of groups. So I have 2 2s in a group, and I have 2 3s in a group. So my least common denominator is 2 times 2 times 3 times 3, which is 36. You may have also been able to see that right away. That is fine. But this is the trick that we can use. It'll work every time if you struggle with seeing those numbers. Okay, so if I want to find the least common denominator of something that looks like this, again, some of you may be able to visually see what's going on, so I'll explain it the long way first, and then we'll kind of come back and look at it. Maybe you're able to get there. So 4x squared is really 2 times 2 times x times x. 2x is really 2 times x. 8x is really 2 times 2 times 2 times x. So out of each of these groups out of each of these denominators, I'm looking for the most amount of times each factor repeats itself. So 2 and x are my factors, right? Those are the only 2 numbers and variables that I see. So x repeats itself at most 2 times. 2 repeats itself within a given group at most 3 times. So I can have that as my least common denominator. 2 times 2 times 2 times x times x. 2 times 2 times 2 is 8. X times x is x squared. Therefore, my least common denominator is 8x squared. You can also maybe see that. Another way to think of it is ask yourself, out of all of these, 4, 2, and 8, what is the lowest number that all of them can go into? 8, right? And then you look, well, what is the most amount of x's that I see? X squared. That means I would have to multiply this by an x squared, or this by an x and this by an x. So that way it becomes x squared, right? We're trying to just get it to match. We're trying to get the denominators to look the same. Okay, so same thought process can happen here. I'll still, again, go the long way and then kind of talk about it quickly the short way. So 8 can be broken up into 2 times 2 times 2 times x times y times y. 5 is already prime. We can break up the x times x. 4 is 2 times 2 times x. Okay? So again, I have lots of factors here. 2, I see the number 2. So how many times at most do I see 2 appear? 3 times in this group. At most, how many times do I see my x's appear? 2 times in this group. At most, how many times do I see my y's appear? 2 times. At most, how many times do I see a 5 appear? Just once, but we still have to include it, right? If it appears, you got to include it. So we have 2 times 2 times 2 times 5 times x times y times y. So that's 8 times 5, which is 40. So this is 40x squared y squared. Again, another way to think about this is 854. What's the least common denominator? What's the lowest number that all those can go into? 40. So then you think, well, how many x's at most do I see? I see an x squared and a y squared. I need to make sure that my other groups also have an x squared and a y squared in them, right? You can't reduce the amount of x's. You got to match up to the highest amount, okay? All right, so the next one. This one, hopefully, you can see very easily here. I have one denominator of x, one of 2x. I want them to look the same. So what could I multiply this first one by? By 2, right? If I multiply both of these by 2, top and bottom, I now have 2x and 2x. So what is that least common denominator? 2x. All right, what if we have factors that look like this? Factors that are more like expressions, x plus something, x minus something. Okay, so the trick here, you can imagine it the same way. These were all my factors listed out, okay? This is a factor, this is a factor. At most, how many times do I see them? Once. What did we do with all the amount of repeats that I see? I multiplied all of them together. We can do the same thing here. I can say that my least common denominator, I guess I should put this down here, is really x plus 1, x minus 2. I also like to think about it, looking at this fraction, and looking at this fraction, I want them to be the same. So this one already has an x plus 1. I can multiply this by x minus 2, and then I can multiply this one by x plus 1. It's almost the idea, very similar to the idea of your fraction 1/6 plus 2/5. If these don't have anything in common, right? These do not have any factors in common, what do you have to do? You have to multiply them by each other, right? 6 and 5 can't go into each other. You have to multiply 6 times 5. Same thing. These factors have nothing in common. You have to multiply them by each other. Same thing. So that's kind of a strategy that you can use if you see something like number 6. Okay, number 7, we have same idea here. This and this, not in common, but let's take a look at this. This can be factored. So we also want to keep asking ourselves the questions, check for factorability, right? If we can break it down and save ourselves some time, because sure, you could multiply x times 5, x minus 5, x squared minus 25. You could multiply all three of those things together, but that's not the least common denominator. Let's try to break this down. So this is your difference of squares. Difference of squares becomes x plus 5, x minus 5, right? You can only do this if you have a binomial that's being subtracted. So what do we notice? These are repeats, right? Here's kind of my least common denominator. I have x plus 5, x minus 5. How would I get this one to look like that? Well, I'd have to multiply this group by an x plus 5. How could I get this to look like that? I'd have to multiply this one by an x minus 5. And then at that point, all of my denominators have an x plus 5, x minus 5. So that is my least common denominator, right? Again, you can think about it. At most, how many times do I see these groups appearing together? Once, right? Once. Okay, so then we can look at this next one, and we want to do the same thing. We want to factor. Okay, so for this one, we can break down this, we can factor this down. So we have x minus 4. And so we're at the point where we're kind of looking again, and this x squared can be broken into an x times an x. So there's, again, the two ways to think about it. The first one is how many times at most do I see each factor repeat itself? Well, I have a factor of x, and I have a factor of x minus 4. Remember, everything in parentheses is considered one factor. Even though there's a couple things happening in here, it's in one group. It's grouped up in the parentheses there. So at most, I see x appear twice, and at most, I see an x minus 4 once. If it would be different, if you had a squared, if you had like a squared symbol, that's a different story. Then you would say, oh, I have x minus 4 appear twice, but you don't. So what would be my least common denominator? The x times the x times that x minus 4 factor. How do we write that? That's x squared times x minus 4, okay? Another way to think about it is going through each group individually and saying, all right, what do I need in this group to get it to look like this group? Okay, well, this group has an x. This one doesn't. So I definitely need to put an x here, right? But look, this group has 2 x's. So actually, each group needs another x added in, and then this group here at the end needs an x minus 4, which is why that's your least common denominator. So you can think about it like that as well. Okay, so our steps here, we want to, again, factor. I already said that. Factor first if necessary. Then we're getting that common denominator. That's by finding the least common denominator and creating your equivalent fractions. You're then going to add and subtract the numerator, and we keep the denominator. So that is the same as yesterday. Same fraction rules as yesterday. We just have the initial step now of getting the same denominator. So I want to look at 12x and 6. So we're thinking, what can I do to get 12x and 6 to look the same? Well, I know 6 goes into 12. I can multiply that by 2 and an x, right? I need it to be an exact match. So I have 5 over 12x plus 7 times 2 is 14. X times x is x squared over 12x. I now have the same denominator. So I'm going to write my answer in standard form, though, highest degree to lowest degree. And at this point, we check for factorability. I can't factor anything, right? 14 and 5 don't go into each other. I don't have an x in every term. We're good to move on to the next one. Okay, so for this next one here, this is the same idea of what I was talking about earlier. It's kind of like we have 2 totally different factors in my denominator. It's like that 1/6 plus 2/5 thing. They're not the same at all, nothing in common. What do we have to do? We have to multiply them by each other. So my least common denominator here would be x plus 4 times x minus 3. So I'm going to multiply each fraction by the other denominator, right? But I need to make sure to do that in both the numerator and the denominator. So that way we're not changing the value of my equation at all. So I'm going to extend this out. This is x plus 4, x minus 3. On the top, I have x plus 4, x minus 2. Also, as I'm filling this out, I want to make sure we're actually listening to me. So if you are listening to me, thank you. And if you are, please private comment your favorite thing that has happened on iCarly, the TV show, your favorite moment from iCarly. Okay, so at this point here, do not do this. Do not do this, okay? Do not cancel these out, right? Do not cross cancel because they're being added. And also, even if you could do this, if we broke the laws of math, what have we just done? You've just completely gotten rid of this factor. Now we don't have the same denominator. Now I can't add these, right? So don't cross cancel. Cross canceling when you're adding is not a thing because you do not want to change the denominator. What do we have to do? We need to simplify this and combine like terms. Distribute, combine like terms. So I'm going to do that. I'm going to just write this in a different color here. X times x is x squared. X times negative 2x. 4 times x, so negative 2x plus 4x is a positive 2x. 4 times negative 2 is negative 8. 2x times x is 2x squared. 2x times negative 3 is negative 6x. All over x plus 4, x minus 3. Okay? So now I've distributed. Now I can combine like terms. X squared, 2x squared gives me 3x squared. 2x minus 6x, which gives me negative 4x. Minus 8 all over x plus 4, x minus 3. So you want to then, at this point, check, can you factor this? And I'm going to go fast here. No, you cannot factor this, so this is your answer. That is a possibility on the homework as well. You may have a trinomial that you cannot factor, and then you are done. Okay, so let's move on to the next one. I can break this down. I want to factor first because right now, I mean, you could multiply these by each other, but you would just be creating more problems for yourself. You want the least common denominator. So if we factor this first, because this is a difference of squares, this is really x plus 2, x minus 2. So I don't have to change this one at all. I'm just asking myself, well, what do I need to add into this other denominator? Well, I just need to multiply that by x minus 2. So that way you're only having to multiply one of the fractions, right? Make it easier on yourself. You want to factor. So we have, and also pay attention to this subtraction sign, okay? So I'm going to write this out kind of in a long way, so that way I'm not accidentally losing my negative here. So I have x plus 6 minus, I am going to expand this though. 3x times x is 3x squared. 3x times negative 2 is negative 6x. But they're being subtracted, so I can really change my signs here. So please do that, otherwise you're going to get this wrong. So keep the denominator. I can combine like terms in the numerator. X plus 6x is 7x, but I do want to write this in standard form. So I'm going to put that negative 3x squared first. Plus 7x plus 6. I'm at the point to save time. I am going to just put the answer down. You can factor this. Your factors are x minus 3, 3x plus 2 from your numerator, okay, from your numerator, with a negative kind of pulled out because of this. So again, this becomes this. Factor on your own time. You'll have to factor on your homework, but I'm just saving time here. And then in the denominator, we have this. Nothing cancels. So this would be my answer. But you always want to factor it down if you can. Okay, so let's look at number 12. So number 12, we have x minus 3, 3 minus x. Again, these do not have, they are not the same. So you could multiply this side by 3 minus x, this one by x minus 3, because, right, that you can't break that down, you can't factor them anymore. But I want to show us a cool trick, because you may be thinking, man, these are really close to each other, right? They look almost the same. You're right, they are almost the same. How could we maybe make this one look like this one? The signs are off, right? The signs are the only thing that are wrong with this. I want this to be a positive x and this to be a negative 3. I can factor out a negative, okay? So again, I'm going to keep that minus here. I can factor out a negative. And so I'm left with negative 3 plus x. But we know, using our commutative property, that is really just the same thing as x minus 3, right? So these are equivalent. And here's where we really have to pay attention. I've pulled out a negative, and that negative is movable. It can move to the numerator. It can move out in front of my fraction. And so we may see it more often as that negative is moved out in front of my fraction. And what do we know when we have a double negative here? Hopefully you're saying we can turn that into a plus sign. Yes, we can. So that's two kind of tricky math rules that exist. If you're like, I don't know about that, again, you can always go the original way of multiplying them by each other. You will just have a little bit more work to do, but that's fine. All right, so because we turn that into a positive sign, I don't have to worry about that negative thing anymore. I can just add across, and I have the same denominator now. So I have x plus 1 plus 5 is 6 over my common denominator of x minus 3. There's my answer. So it'll save you a lot of time. Trust me, it'll save you time if you can remember that rule. Okay, last one here. Again, I'm going to go through fast on the factoring part. So we would need to factor this out first, right? I would not want to multiply this over here and then multiply x minus 1 over here. Let's see if we have some groups that are already matching, where I may not have to multiply both fractions. Let's save ourselves some time. So this becomes x plus 2, x plus 1 if you factor. So you will have to do that on the homework. And yes, look at that. We have a repeat, okay? So I would only need to multiply this fraction over here by x plus 2. And now I have my matching denominators, right? Okay, so I'm going to put this still all over one fraction, but I'm going to write this very carefully, again, paying attention to the minus sign here. So I have 3x squared plus 6x plus 3. That fraction has not changed. Minus all of this stuff that I'm about to distribute, okay? X times x is x squared. X times 2 is 2x. 3 times x is 3x. I think I might have said that weird. But anyways, 3x plus 2x is 5x. 3 times 2 is 6. Okay? Again, all of this is being subtracted, though. Please pay attention to that. So when I combine like terms, this is really minus x squared minus 5x minus 6. All right. So I get 2x squared. 6x minus 5x is 1x. 3 minus 6 is negative 3. All over my common denominator. I'm skipping to the factoring step. Here are your factors. So again, you're going to have to factor that. And what do we notice? We actually do have a cancellation this time. Now I can cancel. So my answer is 2x plus 3 over x plus 2. Thank you for listening. I am also posting the other video if you need a little bit more explanation on the factoring. She does that. But tomorrow we will review over this lesson for those of you that missed it today. So if you have any questions, let me know. I'd be happy to help.